Lecture problem 2. A spring gun placed on a table fires a steel ball at a 45-degree angle above the horizontal. The ball leaves the muzzle of the gun 1.1 meters above the floor and travels 4.6 meters horizontally. Determine the total time that the ball is in the air. First, let's sketch the motion of this projectile by means of a diagram. The ball is launched at an angle of 45 degrees above the horizontal with a velocity v0. This velocity v0 is not given to us, but because the angle is given, we can break it into two components, the v0x and the v0y. The v0x can be obtained using the trigonometry of this right triangle. The v0x equals the v0 cosine the angle of 45, and since the cosine of 45 equals to square root of 2 over 2, we can write down this expression in the following form: v0 square root of 2 over 2. In a similar way, we can obtain the v0y to equal v0 sine the angle of 45. Again, the sine of 45 also equals square root of 2 over 2, therefore the v0y equals v0 square root of 2 over 2. As you see from the diagram, the launching point is chosen to be the origin of the system coordinate, therefore this point is going to correspond to 0x and 0y. Since the ball is going to fall, according to the question, 1.1 meters below the launching point, therefore at the moment when it hits the ground, the value of y is going to equal negative 1.1 meters. According to the question also, the horizontal displacement of the ball is going to be 4.6 meters, which is the following. Let's write down the displacement along the y and the displacement along the x right here. So y equals negative 1.1 meters, and the horizontal displacement x is going to equal positive 4.6 meters. Since the question is asking for the total time from the time it is launched all the way until it hits the ground, in principle we can use either the x motion or the y motion. The x motion can be represented by the following equation: x equals x0 plus vxt. We know that the x, which is the horizontal displacement, is positive 4.6. x0, which is chosen in my system coordinate to be 0, plus the vx, as obtained earlier, is v0 square root of 2 over 2 times the time t. Notice that this equation has two unknowns, therefore we cannot solve for the time because the v0, the initial velocity, is not known to us. Because of that, we can try the motion along the vertical. Since along the vertical we know the y displacement, therefore let's use an equation that relates the y displacement to the time, which is the following equation: y equals y0 plus v0y times the time t plus 1/2 negative g times t squared. The y is equal to negative 1.1. The y0 is chosen to be 0. The v0y, like the v0x, is equal to v0 square root of 2 over 2 times the time t. The next expression, 1/2 times negative g, you must know by now that equals to negative 4.9 because the gravity equals to 9.8 times the time squared. Notice in this new expression also we have two unknowns, the time t and the velocity v0. Therefore we cannot solve for the time unless we know the velocity v0. In this case, we need to use the two equations. We call that one simultaneous equations. In general, people would isolate the v0 from the x equation and plug it into the y equation. But if you pay extra attention, you're going to notice that this term here, v0 square root of 2 over 2 times the t, is repeated again in the y equation. Therefore, all you need to do is substitute the entire term of v0 square root of 2 over 2 times the time t by 4.6. As a result, this y equation is going to look like this. Negative 1.1 equals, this entire term now equals to 4.6 minus 4.9 times the t squared. Rearranging this equation by moving the negative 4.9 times t squared to the left-hand side of the equation, it becomes positive 4.9 t squared. Move the other terms to the right-hand side, you get 4.6, and the negative 1.1 becomes positive. As a result, the equation is reduced to 4.9 t squared equals 5.7. Solving for the time t, you obtain 1.08 seconds.